Okay, properties of logarithms. Laughing at Corona means in February, in March, last week, this morning, a little later this morning. Please wear your masks. I just want to go back to normal. I think if we could all just take this really seriously, this might go back to normal sooner rather than later, but I don't know. I feel like I'm just talking to a screen. It's my life. Okay, properties of exponents. So, remember our properties of, properties of exponents. So, like the product rule, when you were multiplying the bases, you added the exponents. Power rule, at power raised to a power, you multiplied them. Quotient rule, you subtracted. Negative exponent dropped, 0 exponent equals 1. Okay, these go along pretty well with the logarithm rules, okay? So the product property of logarithms is pretty much identical to the product property of exponentials. So of exponentials, you add. If these are being multiplied inside of a logarithm, you add them, okay? So, dude, multiplication is like advanced adding, which he's not wrong. It is. So, if we wanted to condense these, so we want to make these one logarithm. Well, the biggest thing here is that the bases have to be the same. Okay, so we have log base 2 and log base 2. Since there's an addition sign between them, we can combine those by multiplying. So then we can make that into log base 2 of 7 times 4, which is log base 2 of 28. Okay, on this other one, so we have log base 4 of 2x, log base 4 of 4x squared. Well, we can combine those to be 2x times 4x squared, which is going to be 8x cubed. So that's log base 4 of 8x cubed. Cool? What if we want to expand them? Okay, so we want to expand using the product property. Well, this first one, we have log of 6. Well, 6 is the same thing as 2 times 3, right? So I could just rewrite that as 2 times 3. And then that's going to be log of 2 plus log of 3. So multiplication goes with addition. Here, log base 2 of 5x. Well, that's the same thing as 5 times x. So this is going to be log base 2 of 5 plus log base 2 of x. Cool. So product multiplication goes with addition. What about quotient? So the quotient rule of exponents was we subtracted, right? Well, guess what? Shocking. We're going to do the same thing with logarithms. So if we have log base b of m over n, that's the same thing as log base b of m minus log base b of n. This is subtraction. What is that off of? It's off of like some war movie. I like that guy. I like that actor. He's a good actor. Anyways, so log base 3 of 24 minus log base 3 of 8. If we want to condense this to a single logarithm, well, they have the same base, and they're subtracting, which subtraction goes with division. So that's going to be log base 3 of 24 over 8, which is log base 3 of 3. Which, fun fact, that equals 1. Okay, this one, so we have log base 4 of x to the 9th minus log base 4 of x squared. Well, the log base 4s are the same, so that's going to be log base 4 of x to the 9th over x squared, which x to the 9th divided by x squared is x to the 7th. Okay, what if we wanted to expand? So let's expand these. So if we have log no base of m over 7, well, that's the same as log base m minus log of m minus log of 7. 4, we could rewrite that as 8 divided by 2. You could have also done like 16 divided by 4 or 32 divided by, what is that, 8? 8, 16, 24, 30, yeah, divided by 8. So I'm just going to do 8 divided by 2, which can be rewritten as log base 8 of 8 minus log base 8 of 2. Okay, so subtraction goes with division. Okay, what about power? So the power rule over here is we multiplied, right? When we had a power raised to a power, we multiplied the exponents. Now this time it's kind of a weird rule, but it still goes with multiplication. So if we have log base b of m to the nth power, we're just going to take that n and you're going to multiply it in front. So that's the same as n times log base b of m. Okay. That's weird. Okay, so basically, if we want to condense these, so we have 5 times log base 4 of 2. We can just move that 5 up to raise it the 2 to the power of 5. So that's the same thing as log base 4 of 2 to the 5th, which 2 to the 5th is 32. So we could just write that as log base 4 of 32. This one we have 1/3 as our exponent. So we have 1/3 log of 8. So that's going to become log 8 to the 1/3 power, which 8 to the 1/3 power is 2. And you could check that in your calculator if you want. Okay. Expanding these, so if we have log base 2 of 8 to the 7th power, well, I'm just going to move that 7 out to the front. So that's going to be 7 log base 2 of 8. 3 log base 4, or log 4 of x minus 1. Well, I'm just going to move that x minus 1 to the front. So that's 3 times x minus 1 log of 4, which that could be 3x minus 3 times log of 4. Okay, log base 7 of the square root of w. Well, square root of w is the same thing as w to the 1/2 power. Then we can move that 1/2 to the front. So that's 1/2 log base 7 of w. Okay, so those are the 3 properties: product, quotient, and power. So multiplication goes with addition, division goes with subtraction, and power becomes multiplication. So let's do some examples of condensing and expanding these. So this first one, if we want to rewrite this as a single logarithm. So the first thing I'm going to do here is the power property. Okay, we're going to use order of operations still. So you do multiplication first, or parentheses, exponents, multiplication, division, addition, and subtraction. So this would technically fall under, like, I guess, exponents. So I'm going to move those first. So then I have log base 4 of a to the 4th plus log base 4 of b squared. Now these are the same, and they're being added, which means that addition goes with multiplication. So this is going to be log base 4 of a to the 4th times b squared. Cool. Let's see. There we go. Let's do this one. So if we have 7 log base 3 of u minus 3 log base 3 of v squared. So I'm going to start with my exponents. I'm going to move these. So this is going to be log base 3 of u to the 7th minus log base 3 of v squared cubed, which this is a power raised to a power, so I'm just going to multiply those. So this is going to be log base 3 of v to the 6th, and then log 3 of u to the 7th. Bases are the same, and they're being subtracted, which means we're going to use the quotient property. So then this is going to be log base 3 of u to the 7th over b to the 6th. Cool? Click through, fill the power. It's embarrassing. Okay. This one. So log base 2 of 4 minus log, or plus log base 2 of y plus 1/2 log base 2 of 49. So the first thing I'm going to deal with is this power. So that's going to be log 2 of 49 to the 1/2 power, which I would put that in your calculator, or this is the same thing as the square root of 49, which the square root of 49 is 7. So this is going to be log base 2 of 7. And then we still have the log 2 of y and the log 2 of 4. Okay, then we're just going to go left to right. These are all being added, so I'm going to add these first two. So that's log 2 of 4 times y. And then plus log 2 of 7. Again, we have the same base, so this is going to be log 2 of 4 times y times 7, which is log 2 of 28y. Cool? Let's see, blah, 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 blah. Perfect. Okay. One more, maybe, I don't know, maybe I did. So this one, parentheses first. So I'm going to work inside these parentheses first. So they're being added, so that's going to be log base 5 of 8 times 27, which 8 times 27 is 216, so this is log base 5 of 216. Then I'm just going to bring this 1/3 minus log 5 of 3. Now, technically, those parentheses could be gone, right? So I could just rewrite this as 1/3 log base 5 of 216 minus log base 5 of 3. Deal with that power, so I'm going to move that. So it's going to be log base 5, 216 to the 1/3 power minus log 5 of 3, which that 216 to the 1/3, that's really the same thing as the cube root of 216. And we can put this in the calculator either way. You get 6. So this is going to be log base 5 of 6 minus log 5 of 3. Bases are the same. We have a subtraction, so I'm going to use division. So this is going to be log 5 of 6 over 3, which is log 5 of 2. Okay, let's see, blah, 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 blah. Perfect. How many did I do? Okay, we're going to just skip through this one. Okay, let's go to expanding. So here, taco cap, love it. Basically, we're doing order of operations opposite, okay? So see how these are all being multiplied here? Well, I can write this out as log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. Now I'm going to take this 4 and I'm going to move it to the front. So this is going to be log 6x log 6y plus 4 log 6z. And you're done. Perfect. This one. So we have log 4. All right, this one. So log base 4 of a to the 9th b over b. So this is the quotient property, right? Because they're being divided. So we're going to subtract them. So that's going to be log base 4 of a to the 9th minus log base 4 of b. And then I'm going to move that 9 over to the front. So that's 9 log base 4 of a minus log 4 of b. Cool? Check it. Perfect. Okay, let's do another. So log base 4 of q to the 4th r squared all squared. So on these ones, I would just move that in first. So do the power raised to the power. So this is log 7 of q to the 8th r to the 4th, which then that becomes log 7 of q to the 8th plus log 7 of r to the 4th. And then I can move these to the front. So this is 8 log 7 of q plus 4 log 7 of r. Let's check. Perfect. Okay, this one. So again, I'm just going to move this in first. So this is going to be log 2 of y squared over z to the 10th, which is log 2 of y squared minus log 2 of z to the 10th. And then I'm going to move those to the front. So this is 2 log 2 of y minus 10 log 2 of z. Cool. Let's see. All right, yeah, let's go through these two, I guess. So if we have the square root of 7x cubed. So this, we can write a square root as a power of 1/2. Okay, and then I could move this in if I wanted to. So this is going to be log 7 to the 1/2 power, and then x to the 3/2 power, which is going to break up to be log 7 to the 1/2 plus log 7, or not 7, x to the 3/2, and then we can move these to the front. So this is 1/2 log of 7 plus 3/2 log of x. One more, then we'll be done. So let's do this one. So this is raised to the fourth root of m to the 5th n squared. So I can just rewrite that to the 1/4 power. This was a 1/2 power because there's technically a 2 right there, so that becomes 1/2. That's a 4, so it becomes 1/4. And then that's going to be log base 3 of m to the 5/4 n to the 1/2, because 2 times 1/4 is 1/2. And then that's goes with addition, so log base 3 of m to the 5/4 plus log base 3 of n to the 1/2. Move those to the front, so 5/4 log base 3 of m plus 1/2 log base 3 of n. Sweet. Goodbye.